What is carbonic acid and how does this very weak chemical compound cause erosion? Well, with this combination of carbon dioxide and water, the outcome is said to be almost like the carbonation in your soda. Of course, soda is much stronger, but the effects are pretty similar. That being said, carbonic acid is especially effective at dissolving limestone. As you can see in the first few pictures, all the gravestones are the same material, same model, same place. However, the dates are from different years. The first tombstone you see is from the year 1986, and as the years get further from today's date, the erosion increases. Now, this may not seem like much of a difference in years, but you can definitely see what time has done to change them. But how does this happen, and how can you tell? Well, over time, the chemical weathering coming from the carbonic acid causes the limestone in the grave marker to no longer be smooth. The water holding the acid breaks away at the rocks and carries the pieces away little by little. After those tiny little pieces are rotted away, little curves, dips, and sometimes even cracks will appear on the surface of these rocks, and water soon fills them to allow lichens to grow. Lichens are those little green things. This might not seem like much, but with the lichens growing, biological weathering starts. So not only is the acidic compound causing a breakdown to the rock, it is allowing the lichens to break down the tombstones, furthering the erosion process, which isn't so good if you pay a lot of money. Now, let's talk about the history of carbonic acid and kind of understand the background of things. In 1757, Dr. Brownrigg discovered this chemical compound. However, the gas form was found by Joseph Black, a Scottish chemist and physician. But for the purpose of this project, I want to somewhat focus on Dr. Brownrigg because he was technically the first to know of its existence in the first place. It was found in the Pyrmont waters in Australia, whereas the name carbonic acid was given to the molecule in 1787, roughly 30 years later. However, this compound is not only found in the form of acid rain, but comes in many other natural occurring things, such as your blood, fermentation, coal, groundwater, and oceans, meteors, volcanoes, amino acid, proteins, and sulfur deposits. So there's a lot of places you can find this, only I'm using acid rain because I don't know where I could find the proof for the other ones. Fun fact, the effects of acid rain on cemetery stones is clear enough that even the Geological Society of America once tried to use this phenomenon as an indicator of how much acid rain falls in a region. So you can imagine how predictable the effects are. Now, I'm going to be talking about the exposures and the effects of carbonic acid. Though it has acid in the rain, it is safe for human consumption and exposure, well, within tolerable acidity. So unless you somehow manage to get it concentrated enough, then you are fine. However, this weak form of acid does corrode away matter over time, making its presence known but not too bad for humans. That being said, if you were to walk in acid rain or even swim in an acid lake, the effects are no more dangerous than walking or swimming in clean water. The air pollution, however, like the stuff that causes the acid rain in the first place, that ain't so good for our lungs. That can actually damage our lungs or just irritate it. But in water, it's fine. So to recap, this video, or whatever I would call it, about carbonic acid and the effects it has on tombstone. The reason I picked tombstones is, one, because they are already dated, and two, people don't seem to move them much, so they have time out in the rain. Another thing I would like to point out is that I really didn't know much about this topic, but after researching it and what it does and the history of it, I'm glad to say I really enjoyed learning about this type of weathering because I only thought Japan had things like acid rain, and I thought it was like actual acid, not just like carbonation. So, yep, the end.